Hold on tight because the universe just unleashed a cosmic whopper. Astronomers have discovered a spinning behemoth that puts the size of our Milky Way to shame. Picture this: a massive object 60 times larger than our galaxy, swirling in space like a celestial dance party. It's a mind-boggling discovery that's sending shockwaves through the scientific community and redefining our understanding of the cosmos. Get ready to be awestruck by this spinning object that's simply out of this world. What are shockwaves? Shockwaves in the galaxy are powerful bursts of energy that are often associated with astronomical events such as supernova, galactic collisions, and the activity of supermassive black holes. These shockwaves can cause the interstellar gas and dust within a galaxy to compress and heat up, leading to the formation of new stars. Supernova, for example, are explosive events that occur when a massive star reaches the end of its life and collapses in on itself. The resulting shockwave can blast outward at speeds of thousands of kilometers per second, causing nearby gas and dust to heat up and form new stars. How do experts find giant shockwaves in space? Like sonic booms from supersonic jets, modern radio telescopes may see the propagation of a pair of massive shock waves that two galactic clusters created as they pass through the newly formed cluster. When these rapid electrons traverse a magnetic field, they generate radio waves, which we can view with observatories like Mir-KT from Earth. Daily Mail said an elaborate network of light filaments threads the shocks, tracing the locations of both huge magnetic field lines and the places where electrons are propelled within the wave. These shock waves are still traveling at 932 miles per second, or 3.3 million miles per hour, through the galaxy cluster formed due to the collision. Researchers find giant shockwave. Able 3667, a supercluster formed by merging two galaxy clusters, caused that shockwave. According to estimates by Professor Francesco de Gasperin during his time at the University of Hamburg and INAF, this was one of the most energetic occurrences in the cosmos since the Big Bang. It ejected a wave of electrons akin to a particle accelerator when it happened around 200 million years ago. Those particles are still moving at Mach 2.5, 1500 m/s, and generate radio waves as they pass through magnetic fields after all these years. Dr. de Gasperin and his colleagues spotted the radio waves using Mir-KT, a new telescope array in South Africa. The XM Newton X-ray Observatory also concentrated on Able 3667, but radio signals alone weren't adequate to define the shockwave. The scientists scanned both halves of the shockwave's radio component, often known as radio relics. According to the researchers, the shockwave first blasted into being about 1 billion years ago, when the two galaxy clusters that make up Able 3667 first collided. Galaxy clusters are the most enormous gravitationally bound structures in the universe. When two of them merge, they release the largest amount of energy in a single event since the Big Bang, the researchers said. As the wave shot electrons into space at near light speed, the particles tore through magnetic fields in the region, emitting the twin arcs of radio waves seen today. The researchers found that those radio arcs each move at more than 3.3 million miles per second, 5.3 million kilometers per second, and are about 13 million light-years apart from each other, and each measures 60 times larger than the entire Milky Way galaxy, which spans about 100,000 light-years in diameter. The Sagittarius A. Sagittarius A, often abbreviated as SCAR-A, is a supermassive black hole located at the center of the Milky Way galaxy. Its mass is about 4.1 million times that of the Sun, and its diameter is approximately 44 million kilometers. SCAR-A is located about 25,000 light-years from Earth, in the direction of the constellation Sagittarius. Its presence was first inferred by studying the motions of stars in the Milky Way's central region, and it has since been observed using a variety of telescopes and instruments across the electromagnetic spectrum. SCAR-A is of great interest to astronomers, as it provides a unique opportunity to study the properties and behavior of supermassive black holes, which are thought to play a crucial role in shaping the evolution of galaxies. Galaxy clusters. The largest ones contain thousands of galaxies and are called galaxy clusters. Sometimes two galaxy clusters start attracting each other through the force of gravity, leading to an inevitable collision. Collisions of galaxy clusters are the most powerful events that occur in our universe, and they can generate spectacular fireworks that can be observed using modern radio telescopes. When two galaxies collide, astronomers can witness the propagation of a pair of gigantic shock waves through the newly formed cluster, similar to the sonic booms from a supersonic aircraft. The shock waves act as giant particle accelerators that accelerate electrons to speeds close to the speed of light. When these fast electrons cross a magnetic field, they emit the radio waves we can see. The shocks are threaded by an intricate pattern of bright filaments that trace the location of giant magnetic field lines and the regions where electrons are accelerated, notes INAF staff researcher Francesco de Gasperin. These shock waves are still propagating through the newly formed galaxy cluster at the very high speed of 1,500 kilometers a second, corresponding to a Mach number of 2.5. The size of the main shock wave is impressive, spanning the entire width of the galaxy cluster for a total size of 6.5 million light-years. For comparison, the Milky Way is more than 60 times smaller than this shock wave. In conclusion, the discovery of this spinning object 60 times larger than our Milky Way galaxy is a monumental achievement in the field of astronomy. It not only challenges our understanding of the universe, but also opens up a whole new realm of possibilities for future exploration and research. As we continue to uncover the mysteries of the cosmos, let us marvel at the vastness and complexity of our universe, and remain in awe of the incredible discoveries that await us. If you found this video informative, make sure to hit the like button, share it with your friends and family, and subscribe to our channel for more exciting content like this.